that my filter needs to adapt. Okay, very good point. What else? What else do I have? What do you need to compute, for example, something like this? I want to put the real practical set now. Expectation of Bn Xn. Right? That is expectation then. Take across n. It is infinite. It's infinite, right? To find out the expectation, remember I can integral all the n, right? And in practice, I might not be able to compute this thing for all value n. Well, I mean I have to wait. So in practice, to compute this. So this is a thing. Let me put here. Of Xn. So this requires to have an infinite sum, right? To find out the integral difference, take all the value. But now we assume that we only do not have this because it's a model. To find out the mean of this, so this is the mean of this signal, right? In n. And let's say I only have so the mean of this. The mean of this, let's say I can only take the window of the signal coming in here, and can only take a small window. In practice, I may make a empirical mean, right? I take this window of n sample and I take the mean of that, right? I cannot just wait the signal run forever and then take the sum and take the mean, because I cannot take this. I only can take a small window and I estimate the mean here. Right, and that is what we can solve our problem, because let's say when it's running the system inside this room, and Kim will show you something more very soon. I cannot wait forever. I have to make the filtering. So maybe I take some training, I send some signal and test, and I get something. And I check that before I send something over the wireless channel, I take the first 5 milliseconds, for example, of those noise. And I take that, and I can compute the empirical mean, and I can plug it into my system. Right? So you see that, the two problems. Okay, theory requires the statistic doesn't change with time, and it requires you to have a distinct at hand. But in practice, we don't have that. So now we're going to move to more practical setting now. Okay? So quickly. Alright, so alright, so moving now to adaptive filter, and I realized that I'm very slow behind the schedule, so I'm going to describe to you the concept of adaptive filter, quickly the LMS algorithm, without the conversion theory behind it. I let you read that at home, and I will let you see the magic when that thing runs in MATLAB. So here the signal is my favorite signal here, and I use, here's my output line. Here's my output line. And the filter is a line N filter. So this is H. H of 0, 1 to N minus 1. And I have here with me is N, N minus 1, N minus N, minus plus 1. And taking this vector, multiplying this vector, giving me this sample Yn. Okay? So that's the thing. And I'm going to follow one suggestion. Is now I let this filter change with time. So early on I have y of n equal to, what do we have? We have equal to x of n as a vector. But x of n is this. X of n is this vector. Not the x of n as a vector. And this is a filter. We have got this filter now, time transpose, time h. So early on I have got the filter is a fix. But now I'm going to let the filter vary with time. If the filter varies with time, all I need to do now is I change this now to n. So I have the filter now also vary with time. So the filter vary with time. Alright, I can let the filter vary with time. Okay, you're still with it. I let the filter vary with time, and my idea is the following. Adaptive filter is the following. First, I have a signal and I have the output that I need to compute right away. I cannot wait to solve the Wigner filter solution. So I start with something. I just start with some guess. And I compute the output. And then I may find some error. And I use the error to help me now to slowly adjust the filter. Adapt and slowly adjust. So that is very good, right? So, okay. So the idea here, start with a filter H0, right? So H0. H0 here is one vector, already sample. And let the so the thing here is after I get y, I let arrow n here, which is equal. So I type it and I can compute. Here's my desired output. And right away I make the computation. So this is actual and this is desired. Let this thing here to adjust the edge of n plus 1 equal to something, some adjustment of this edge of n. Right? Or maybe more precisely, I do like to take something simple. Maybe I just take. So I have something like hn here, and plot with some mu, time with the delta of n. Alright, so that's the idea, and this is adaptive filter. Okay, so let me repeat the concept. I start filtering and I get output by the way. And when I do that, I get some error, right? And I get error and I take that and I can now update my filter for the next instant based on the previous one and some change. By doing that, I solve both problems mentioned earlier on. The first one is if the condition changes, my filter will change. Not because I keep adapting it. Second, I don't have to wait forever because right away I can make the run. Maybe it makes some wrong mistake. Pick up the cell phone, the first few milliseconds you didn't hear very well, but very quickly the system adapts. It has an ability to learn, and it works. Right? It's really like if you go to the US now, you have to make a bubble, you do the homework, maybe you make a mistake, you get some feedback, and then maybe very quickly you adapt to the environment. So that's the idea. Right? It's not like we wait there forever, let me just